All right, we are starting in on 7.2 on sampling proportions, and I just want you to be aware that we're talking about in this chapter, forgot my pen, proportions, which is going to be P or P hat. It's very important because in 7.2 we're going to be talking about means and X bars. That's when we're dealing with proportions only. So, first of all, I'm going to give you a little scenario about Reese's Pieces, and if I was there, I would give you all Reese's Pieces today, but I'm not, so anyways, I'm going to show you, there's a little candy generator here, and let's say the probability of getting an orange candy is 50%, and let's say we take a sample of 25, alright? So we're going to take 25 candies and count how many are orange. All right, now let's say we don't actually know the probability, but we're going to sample, see if we can guess what it is. I'm guessing it's 50%, because that tells me that actually. But so I'm going to take one sample and let's just see what happens. So I'm going to animate and it's going to draw out, and this would be one random way I could get orange. And notice I didn't hit, let's show proportion. I didn't hit 50%. My first simulation was at 32%. I was way off. Now the center should be, or I should have gotten 50%. But I can sit and maybe draw a sample, another sample. And hopefully you guys are seeing all this. And there's where the second one is. That was way off too. Wow. Okay. Well, I can animate. I'm not going to animate all these, but let's just do something crazy. Let's do 1,000. We're going to do 1,000 simulations to see what this curve is going to look like. So I'm going to hit, draw, boom, baby. All right. Now, that's if I collect 25 candies and I analyze it. And I write down the answer. That's one of these dots. Just one. Now, there's 1,002, actually. 1,002 dots that form this normal curve. I did 1,000 samples. Now, let's take a look at it. All right. What is the shape of my 25 when I only take 25? My shape. What would you say my shape is? Well, I would say my shape is normal. Wouldn't you? I would say it's normal. I would say it's normal. Normal. Okay. I would say the center. Where is the center located? Now, we talked about this yesterday a little bit. But where would you say the center is located? And I would say the center is, wow, the center is located right at 50%, isn't it? Imagine that. So I would say the center, and I'm going to say the mu, the mean of all of my samples, right? The mean of all my samples is at 0.5. Okay, and then my spread, all right? My spread, what do you think? What does it look like? My spread goes from about, what is that, 20 to about 75, 76. So from 20 to 76. Now, normally I'd put standard deviation in there, but we're just eyeballing the sucker. So 20 to about 76. Okay. Now, like I said, I could put a standard deviation on there, but right now I'm just looking for a general gist. Can you see the pattern? Okay. So, what is going to happen if I make this 50? What if now, instead, I collect 50 and analyze it, and that's one sample, and I get another 50 and I analyze it, and that's another sample? What kind of curve is going to happen? What do you guys think? Huh? What do you think's going to happen here? Do you think the shape is still going to be probably normal? Where do you think the center is going to be? Probably 0.5. What do you think the spread is going to be? All right, well, let's take a look. You should know all of this already. Kind of addressed all of it. Let's change this to 50. And let's just go right away and do 1,000. We're going to do 1,000. Okay, so brand new graph. We're going to do 1,000 samples of 50. Booyah! Right there. Check that baby out. How has this changed now? Center still at 50. Still normal. Range, though. the range looks like it's from about 26 to about 70. 26 to 70. So let's see, from 26 to 70. So the range has gotten smaller. Everything else is the same, right? Sorry, I'm writing with my mouse. And the center is still located, sample of all my proportions, the mean, I should say, of all my proportions, is at 0.5, where it seems like the center is. So the spread has changed. Wow. Remember, for a specific value of p, the standard deviation gets smaller as n gets larger. Remember that. Just like the game we played on Friday, where the people, wanted to pick the person that had most cards because they were the ones probably closest to the average. People with less cards were further away, or had the highest chance of being further away. All right. So this next slide is going to be the 3 rules for proportions that you must have memorized. All right? Just sit down and memorize these suckers. Okay? You will fail if you don't memorize these. Okay. So I'm going to try and make it a little simpler for you. And maybe make it a little harder. Okay. So the first rule, the mean is that. Okay? All right, if it's random, all right, and there's usually 3 tests. We do random, independent, and normal. All right, those are our 3 tests. So this is random. Sorry, I know it's horrible. But if it's not random, that means it's probably biased. And so our center's not going to line up. So it must be random. Otherwise, our centers are not going to be normal. All right? So remember, our mean of our sample proportion should be the same as our true proportion. Next, the standard deviation. What is the standard deviation going to look like? Well, here is your formula. And you can find this in your formula guide if you want to. If you open up your yellow sheet, if you want to pause this now, open up your yellow sheet and try and find that formula. You'll find it. It is under, I think it's page 2 of the formulas, and it should say standard deviation of a 1 sample, or something like that. All right, but the standard deviation only works when this rule has applied. Now, I kind of brought this up a little bit the other day, and that's the symbol I was looking for. Big N represents the population. Hop. Little n represents the sample. So your sample has to be less than 10% of the population. Okay, now I remember talking about that. Now this is what we like to call independent. So we like to check all 3 things. So first of all is our random. If it's not random, we know our center is not necessarily in the right location. If it's not independent, I know the standard deviation won't work. So it's gotta be independent, all right? And so I've got to check to make sure that my sample is less than 10% of the population. And then finally, the last one is normal. And my normal test, all right, and this is different for a proportion than a mean. My normal test, what is down here? What do I have down here? Nothing. Nothing down here. Close out. Close out. All right, my normal test is this. All right, to see if it's normal, I take my sample space times my probability has to be bigger than 10, and my sample space times its inverse has to be greater than 10. That will tell me it's normal. It means I've selected a big enough sample. Soda drink. Barks for a beer. Brought to you by Barks. I should get money for that. Next, story problem. All right, we only have 5 minutes to do the story problem. Let's see how we do this. All right, let's say Mr. Sheeby takes a simple random sample of 120 students at Craig who play a sport. Suppose the real population proportion is 35% of everybody plays a sport. What is the chance his sample of 120 students falls within 2% of the real proportion? First thing, I want to check, is it random? Because if it's random, I know my center of my curve will be right on par. Did I do a random? And check that out right there. Simple. Whoop. Where's the simple random? Right here. Simple random sample. That's what SRS stands for. So I know my center is going to be located at 0.35. Now, it doesn't mean I'm going to hit 0.35. It just means that I know my center of my sampling curve will be 0.35. I'm only doing one sample, though. So maybe I'll be off slightly. The next thing I'm going to do is check dependency. Because if I don't know it's independent, I can't use a standard deviation. My standard deviation might be off. So, is 120 students less than or equal to 10% of the population? Well, now the population at Craig is about 1,700. So, does that work? Is it less than 10% of the population? Check. All right. And then lastly, normal. Does it meet? And I'm taking 120, times it by its percentage, which is 0.35. Now, if this is bigger than 10, I've met my normal. I know this is going to be a normal curve, and I can use a z-score on this baby. So, 120 times 35, I believe that's way past 10. That is yes. What about the reverse? So I'm going to go 120 times its inverse, which would be 0.65. All right, 0.65. That's the inverse. Is that bigger than 10? Sorry, let's see, bigger than 10. Check. All right, so now I know I'm working with a normal curve. I can use a z-score on this thing. I think we might stop there. And if you want to try and do this, and then maybe on Thursday, we can come and see how well you do. I'm looking for within 2%. So I want to see what's the probability that I can fall within 0.33 and 0.37. I want to fall within this area, right? Because that says within 2% of the real proportion. So what's the chances that I fall, or my sample is somewhere between here and here? Okay, well, so we will talk about that on Thursday and work through that a little bit more. Okay? All right, well, that's a good start. Sleep on it. I'll see you guys on Thursday.